All right, everyone, starting Unit 10 on trigonometry. Hopefully the warm-up went okay for you. Let's just start with our definition of what trigonometry is. So trigonometry, you could just think of as the study or the branch of mathematics that uses triangle measures. But our more formal definition is the study of right triangles and the relationships between sides and angles. And you've actually used a little bit of trig before back in geometry where you guys use your sine, cosine, tangent, trig ratios, and that's really what we're going to start with today, but with an emphasis on right triangles. These triangles need to be right triangles in order for us to use these trig ratios. So with that being said, I'd like to start with, and guys, you can just grab these from Google. I just typed in right triangle. And then the other images that you're going to see down here as we start, they're just from your book. So if you want to pause and screenshot the same image that I did from your book, or if you can't find it in your book, you could screenshot it and crop and paste from just this video into your notes. Please feel free to do that. But let's just go ahead and you guys can pause the video. I just want you guys to answer this question of what do we know about right triangles? And that's a pretty broad question, but I want you to go ahead and put anything that you want on here. This is just a brainstorm. What do we know about right triangles? I can't ask you guys to share out right now, but I'll put down some things that come to mind when I'm thinking of right triangles here in just a sec. So pause the video and go ahead and list those out. Okay, so hopefully a couple things that came to mind for right triangles is always 190-degree angle. And we can see that by this little square in the corner. Every triangle is going to have 3 sides and 3 angles. If one angle is 90, well, hopefully we would have written down that the other 2 angles must be acute. Acute meaning less than 90 degrees. And that's because, hopefully we remember this theorem, all 3 angles of a triangle sum to 180 degrees. So if you have one angle that's 90, the other 2 angles are going to have to add to 90, which means they have to be acute. Maybe some of us wrote down the Pythagorean theorem. A squared plus b squared equals c squared. You can use every time. C is the hypotenuse. A and b are your 2 legs. They're interchangeable. And you might not have written this down, but trig ratios is something we're going to be using today, which is just a comparison of 2 lengths in a right triangle. So trig ratios is going to be our next definition, and we're going to focus and have an emphasis on those comparison of side lengths today in this lesson. So a trig ratio just compares, remember a ratio is a comparison, compares the lengths of two sides of a right triangle. Let's just do this. Right triangle. Great. Okay, a little bit later in this unit, we're going to be talking about trig functions. A trig function is just a rule that is defined by its trig ratio. Okay, I know a lot of writing and a lot of definitions here, but we need to put those down anytime we're starting a new unit. A lot of properties and rules and definitions here. And then last but not least is we're going to be using this symbol theta. Okay, and theta is another Greek letter, just like sigma we used last unit. It represents the measure of an acute angle in a right triangle. Okay, so instead of using x, we're going to use this symbol theta. Alrighty. Okay. The last thing I'd like to do is list out our three trig ratios. And there's an acronym that you guys are probably familiar with from back in geometry called SOHCAHTOA, which helps you remember these three trig ratios. Remember that S stands for sine, C stands for cosine, and T stands for tangent. And then the O, H, and the A, those represent the sides from the angle that we're referencing. So for SO, the sine of theta equals the opposite side length of that angle over the hypotenuse. Then I'm going to start abbreviating here, guys, so we don't need to write everything out. Cosine of theta is the adjacent side, meaning right next to, over H, standing for hypotenuse. And last but not least, tangent of theta, which we already know what O and A stand for, so I'm just going to abbreviate opposite over adjacent. And there's actually three more, which are just the reciprocals of these trig ratios. So the reciprocal of sine is cosecant of theta, which would just be the reciprocal, hypotenuse over opposite. Cosecant is the reciprocal of sine. Secant, which is the reciprocal of cosine, so hypotenuse over adjacent. And last but not least, cotangent, which is the reciprocal of tangent, adjacent over opposite. Okay. You guys got those written down. We'll go ahead and we'll find all six trig ratios for theta, and theta is this angle right here. And really what you need the most practice with is identifying where's opposite, where's adjacent. Hypotenuse is always the side opposite of the 90-degree angle. All right, so when we're starting with the sine, we can abbreviate the sine of theta. The sine of theta is just the opposite side, so the opposite of theta would be a side length of 7. And we already talked about the hypotenuse being 25. So sine of theta is 7 over 25. Cosine of theta, actually, let's do the reciprocal right after. Cosecant, we abbreviate cosecant with CSC, would just be the reciprocal, 25 to 7. Cosine of theta is now the adjacent. So if the 7 is the opposite, then adjacent is the 25. And I know there's two adjacent sides, but 25 is the hypotenuse, so we use the adjacent side that's not the hypotenuse, which is your 24. So 24 over 25. The reciprocal is secant of theta, which is 25 over 24. And last but not least, tangent. Tangent of theta is the only trig ratio that doesn't use the hypotenuse. So that would be opposite over adjacent. 7 over 24. And the reciprocal would be the cotangent of theta, which is 24 over 27. Alrighty. Okay, I don't have too much time in this video to show you, but if you guys go watch the GeoGebra link that's posted, and I can show you guys this during office hours, it'll explain what these ratios mean, and it's really just showing what the side lengths are in comparison to the hypotenuse. So the sine of theta is showing that 7 over 25 is at 7/25 the length of the hypotenuse, and the GeoGebra clip really helps explain that. Okay, so please go watch after this video if you want to make more sense of what these ratios mean, and that should help out. Okay, what I'd like us to do is continue listing our trig ratios for the special right triangles. So why don't you guys, after you write this down, I want to find just our three basic trig ratios for the two acute angles. So the sine of 30, cosine of 30, tangent of 30. And then the sine of 60, cosine of 60, and tangent of 60. And then for our 45, 45, 90, same thing. Sine of 45, cosine of 45, and tangent of 45. Those are the only three we need to do for 45, 45, 90, because both acute angles are the same measure. Okay, so why don't you guys go ahead and pause that, use those trig ratios, and remember, so, ka, toa, and use the angle measure now instead of theta to help you identify which side's opposite, which side's adjacent, and go ahead and write those. So pause and work through these 9 trig ratios. Okay, sine of 30, you should have gotten 1/2. Cosine of 30, root 3 over 2. And remember, on the warm-up, if you watch the warm-up, you understand where the 1, 2, and root 3 come from, or the 1, 1, and root 2 come from. Tangent of 30 was 1 over root 3. Don't forget, you can't leave a radical in your denominator, so root 3 over 3. Sine of 60, root 3 over 2. Cosine of 60, 1/2. Tangent of 60, root 3. And hopefully you can see a couple of these ratios repeat in 30, 60, 90 triangles. Same with 45, 45, 90 right triangles. Sine of 45, root 2 over 2. Cosine of 45, same thing, because the adjacent and the opposite side, they're both 1. So we get 1 over root 2, which simplifies to root 2 over 2. Don't forget to multiply top and bottom by root 2 over root 2. And then tangent of 45, 1 over 1, or just 1. All right? Okay, using these trig ratios and our special right triangles, we can solve for some missing lengths. Okay, and we really don't need to set up these trig ratios if we just use the properties that we talked about in the warm-up. So let's look at these 4 examples, and I'll let you get them set up if you need to take a screenshot and copy paste. Most of these problems are from your textbook. I think one I pulled from online. But let's work through these together. We'll do all of them together here, that's fine. Okay, remember your trick for 30, 60, 90. You always want to find the side that's opposite the 30-degree angle first, because then you can just multiply by 2, multiply by root 3, and you have your last two lengths here. The hypotenuse x is just the shorter leg, the 2 root 3, doubled. So 2 root 3 times 2 just gives us 4 root 3. For y is the length that's opposite 60 degrees. This is your multiply by root 3. 2 root 3 times root 3. Well, the root 3's just get us root 9, which is 3, and 2 times 3 is a side length of 6. So we have 6 and 4 root 3. For number 2, 45, 45, 90, you're either going to multiply by root 2 or divide by root 2, depending on what length's given. If you're given the hypotenuse, which is what we have here, and you're solving for one of the legs, you would divide by root 2. Multiply top and bottom. 20 root 2 over root 4, or just 2, and 2 goes into 20 10 times. Remember, if you have one of the short legs and you want to get the hypotenuse, just multiply by root 2. That's for 45, 45, 90 triangles. Okay, number 3. This is probably the trickiest in a 30, 60, 90. When you're given the length that's opposite of a 60-degree angle. Well, you always want to find the shorter leg first, which is going to be this leg over here, opposite the 30-degree angle. Well, now we know that we either multiplied by root 3 or by 2. And if it's the side opposite of 60, we multiplied by root 3. So to go back and find this length over here, x. Well, let's not call that x. We already have x. Let's call it y. Now you do the opposite. You would do 50 divided by root 3. Multiply top and bottom. We get 50 root 3 over 3. And I know that wasn't the side length that you were asked to find. You were asked to find the hypotenuse. But now it's so much easier because you can just take that short leg, multiply by 2, and you have this hypotenuse length. That's just 100 root 3 over 3. We can't simplify anything else, so you're done. All right, and probably the most important piece that I like to finish with is, oh shoot, we don't have a 30, 60, 90 triangle. Now we need to use those trig ratios that we were given to solve for those side lengths. Well, you have a couple options here because you're given two acute angles instead of just one. You can pick whatever angle you want to use. Say you want to start with angle R. If you're going to use angle R, then you have to use the opposite and adjacent sides. Well, you could actually use opposite and hypotenuse. You just cannot use adjacent and hypotenuse because those are two unknowns. So pick one of the known sides, which is the opposite side, and the two trig ratios that have opposite would be SO and TOA. They both have opposite. So whichever one you want to use, I'm going to use sine. Sine of 27 equals the opposite side, which is 12 over x. Multiply both sides by x. We get x times the sine of 27 equals 12, and we're going to divide the sine of 27 over. Okay. Punch that into your calculator on Desmos. Use Desmos Scientific. We get x equals 23, and just round to the nearest tenth, guys. 23.6. Great. Now let's go ahead and use, we need to find the hypotenuse now. We need to find, I'm sorry, guys. I'm sorry, let me fix that really quick. Sine is opposite over hypotenuse, so you were actually solving for y here. My apologies. You were actually solving for y here. Okay. So you would have gotten a different number. You would have actually gotten 26. 0.4 for your hypotenuse for y. Sine is opposite over hypotenuse, not opposite over adjacent. Now you can use tangent of 27 and using opposite over adjacent. And now we can solve for x. Multiply both sides by x. You're going to end up dividing tangent over, so x just equals 12 divided by the tangent of 27. And we get x equals, there's your 23.6. Okay? So when you do not have a 30, 60, 90 or 45, 45, 90 special right triangle, here's where you need to use the sine, tangent, or even cotangent trig ratios. And you could have used the 63. I didn't use the 63 at all, but if you use the 63, then you were going to be using cosine because that 12 was an adjacent side. Okay, you have the option there when you're given both acute angle measures or you're given one of your side lengths. Okay, let's try another example. Let's say we are standing here looking out at, we can draw this one together, looking out at DeSales Hall. I know it's hard for us to visualize, haven't been there in a while, but here's DeSales Hall and we want to find this height. We want to know how tall DeSales Hall is. Well, if we're standing on flat ground here, we know we have a right triangle, and if we just can find this angle measure, theta, we're going to pick some measure here. We can actually find the height. Let's say this theta is 35 degrees. Okay, and we actually call this angle here an angle of elevation. If that angle is 35 degrees and we're standing, say, 30 feet away, well, we can solve for this length, and then the whole height would be x plus whatever, however tall we are. So let's say we're about, we'll say 6 feet, or you can use 5 feet. That's fine, 5 feet. 5 feet tall. Well, if we set up our trig ratio, this side length opposite of our 35, it's the opposite, and you have the adjacent. So you want to use tangent because tangent uses opposite over adjacent, so x over 30. And when we multiply both sides by 30, we get x equals 21 if we're rounding. 21. But be careful, that's not the full height of DeSales because that angle of elevation was from your eyes to the building. So you actually need to include this 5 down here. So the actual height is 21 plus that 5 feet, this 5 feet right here, to get us a total height of 27 feet. Probably not correct because we don't know what this exact angle of elevation is, but just assuming we did, that would be our height. Okay, why don't you guys pause the video and try and find the length of this ramp right here, given an angle measure of 20, and once again, this side is opposite and you want to use the hypotenuse, so you probably want to use your sine trig ratio. Go ahead and pause this video and I'll work it out with you in a sec. Okay, your ratio should have been the sine of 20 equals the opposite side over x or h. Multiply both sides by x. You're going to need to divide by the sine of 20. When you punch that in on Desmos, your calculator, make sure you're careful with parentheses. You would have gotten a height of 11.7 feet. Okay. All right, that's about all I have for you guys. The last thing I want to put on here is just what our definitions of angles of elevation and angles of depression are. So you can just grab this picture from Google as well. But an angle of elevation, we talked about on the problem we were finding the height of the sails, angle of elevation. They both use a horizontal line. So the angle of elevation is the upwards angle from a horizontal to a line of sight. Okay, so this is our horizontal. The line of sight is up here. For the previous problem, it was the top of the sails. Angle of depression is just the opposite. It's the downwards angle from a horizontal to a line of sight. So in this example, this person's looking at something below ground level, which is fine. It could have been an angle of depression to something on the ground. Okay, but just keep in mind the angle of depression, it's this angle. It's the angle that's from this horizontal down to an object that you're looking at, not this angle. It's the angle formed with the horizontal line and down to whatever object you might be looking at. Okay, that's going to help with some word problems that you guys have on the homework. And once again, you can pull this image from Google if you need to. Alrighty, guys, go ahead and get started on this. You have the notes. You can start the homework, and if you have questions, I can answer them during office hours next week.